Hello, welcome to a new coding challenge video. This is part 2, not really, or maybe it's part 3 or 4 of a video that I made 4 years ago in 2017, the random walker. You're seeing the code for it right over there. And every time I've ever demonstrated this example, I've mentioned how one thing you could consider trying to do is something known as a self-avoiding walk. A self-avoiding walk looks like this. Here's the Wikipedia page for it. It's a random walk where a random decision is made to move up, down, left, or right. But if that spot has already been stepped into, then it can't be stepped into again, and the walker has to choose a different direction. And in theory, it can create a path that fills an entire 2D space. And I'm going to try to take this code example and change it to that today in this video. If I have succeeded, then in the magic of post-production, the final result will be appearing next to me right over here. If I have not succeeded, then maybe nobody will ever be watching this ever again in the future. We'll see. Let me first just review what is a random walker. So this dot here is my random walker. Every frame of animation, it can choose to go one of 4 directions: up, down, left, right. Once again, here we see this is the visual result that we get from the random walker. In order to do a self-avoiding walk, I'm going to need some other data structure to keep track of all of the spots inside of this 2D world. By the way, we should really try, someone should try, maybe I will, making a 3D version of this if I get this done. But I'll come back to that another time. If I think about a very small 2D space, that's 5 by 5, and let's say I start the random walker in the middle, as usual. Now, if it randomly decides to go up, it can go there. Maybe it decides to go to the right. Maybe it decides to go up again. Maybe it decides to go to the left. Now, if it were to try to go this way, down to this spot that's already taken, it can't. It can't choose that anymore. Instead, it should choose to go here. So I need some type of data structure to keep track of whether a spot has been hit or not. And so that could be a 2D array, and I could just put the Boolean value false in all of the cells, and then if it's been there, I can put the Boolean, I can flip the Boolean value to true, and I can use that as a way of checking whether it can go there or not. I'll try that in code now. Getting started, I'm just going to add one variable. I'm going to call it grid. That variable grid will hold the 2-dimensional array for every spot in the canvas. So I need to make a 2-dimensional array, which is kind of a wonky thing in JavaScript. Fortunately, this is something that I've tackled numerous times. I think the first time was in my Minesweeper coding challenge. Not the first time I ever made a 2D array, but kind of talked about it in a video. And in the code for that example, I have this make2darray function. I'm going to grab it, copy it over here to my new self-avoiding walk. I'm going to change this to let, and then I'm going to say grid equals make2darray and have one spot in the array for every pixel. Do I really want to do that? I think so that I can sort of see what's going on more easily. I'm actually going to start coding this by thinking of the 2D canvas as much lower resolution. So I'm not going to, I'll make it 10 by 10. In other words, I want a variable called spacing. Knowing it's a 400 by 400 canvas, I'm going to make it 40. And then I need to have columns and rows. All right, so I've changed this so that instead of just having the random walker walk along every individual pixel, I now have a set of columns and rows based on a cell size, a spacing variable, and then my XY position of the walker is going to be in the middle. And so when I go to draw the walker, instead of, I'll just leave it as a point, but I'm going to make it the stroke weight, half of the spacing. Let's just see that. And then the walker should move instead of 1 pixel according to the spacing. I'm not sure what I just did there. Oh, whoops, I got a major error. I still made the grid with height. So the grid needs to be based on the columns and rows. Oh, and of course the point then isn't just x, y. It needs to be x times spacing, y times spacing. Oh, and it can still go by 1. I see. I can have it changed by 1. I don't need to have it move according to spacing. I'm just going to draw it. It's still moving 1 column and 1 row. I'm just going to draw it by multiplying spacing. Got it. There we go. There's my random walker now. Just to be sure that this is working the way that I think it is, I'm going to make this spacing 5. And then we can see yes. So already, by the way, this is kind of an interesting different visualization of the random walker. You can see that since I'm drawing it with alpha, you can see how many times it's been in a certain spot based on how bright that spot is getting. But the point of what I wanted to do here is I want it never to be able to return to the same spot again. It needs to avoid itself, a self-avoiding walk. Back to 10 by 10 with no alpha. First thing I want to do is fill the grid with the value false. So a nested loop to hit every column and row set to false. Then wherever the walker is, that spot should be set to true because the walker has been there. And as it moves, the new spot every time in draw should be set to true. Ah! What happened? Ah, there's an infinite loop problem. I forgot to change that I to J. Oh, what a nightmare. Let me fix that and see if I can run it now. Okay, great. Oh, we just went straight down. Why is that? Was that just a coincidence? Yes, that was just a coincidence. So I've got an error as soon as I fall off the canvas. Now, I think I need to rethink the way I'm doing this, right? Because now I can't go every possibility. I can't go one of all 4 options. If I'm here, I can only go one of 3 because I can't go down to where I've already been. So before I pick which way to go, I should check all of the possibilities. So checking to the right. As long as to the right is false, and I'm going to make an array called options. And I'm going to put all of the options in there. Options.push. And I'm going to make a little object that says, I have an idea. I have a better idea of how to do this. This is a little bit weird, but just bear with me for a second. I'm going to just make a global variable called options. This is all the ways I could always possibly go. And it's going to have 4 objects in it. Each object should represent to the right, down, to the left, up. And I'll call those dx, as in delta x, delta y. So the first option is to the right, delta x is 1, dy is 0. So I've now very obsessively made an array of objects, each object storing an element that indicates a direction. Right, left, down, up. So then right here in draw, I can just check all of those and see, can I go in those directions? Let every option of options, new x, the next x spot is x plus option.x. So this is the new spot. If the grid, if that spot on the grid has the value false, then it's a perfectly fine option for me to take. And I'm going to call this variable all options. I'm realizing I could use, in a very clever way, the higher order array function filter. I'll leave that to you as an exercise. I have a video about the filter function. Maybe I'll come back and do that later myself. But I want to just write it out the very long-winded way just to really understand what's going on. So I'm going to create a separate array called options. And if it's a valid option, then I will add it to this options array. Now I realize I'm making this kind of confusing because I'm saying options, I'm saying option, and I'm saying all options. Let me just explain that for a second. All options is all the possibilities no matter what. Like it's a global variable, it's never going to change. Now I need to know which options are valid in this particular circumstance. That's going to be my array options. So I'm going to look at every option in all of the options, check to see if it's valid, and if it is, put it in this new options array so that I can say like step equals a random option. Then x plus equals step.x, y plus equals step.y. And I've moved to the next one. So this is just checking which ways can I go and moving forward. Cannot read property and not a number of undefined. Sketch line 52. Oh, I called it dx. So this is dx, this is dy, and this is dx, and this is dy. There we go, perfect. You can see, and I think it would be helpful for me to draw a line between the two. I'm going to use begin shape and end shape to do that. I think this will work. What did I get wrong? So, by the way, what I'm trying to do here is say begin shape and end shape, draw a line between two vertices. The vertex xy, then move to the next place, and then set the next vertex. Why didn't that work? Oh! I forgot about multiplying it by spacing. Oh, I'm always forgetting this. Times spacing. There we go. So we can see the self-avoiding walk. Now I'm getting an error when it reaches the edge. So I also need it to be invalid if it's not a proper spot in the grid. So as long as new x, I'm gonna write a separate function. I'm gonna say as long as is valid new x, new y, and it's not, and the grid spot is false. So I need to write a new function here. Let's say function is valid ij. Let's just say it's, oh, I could actually do both of these in the function. Let me do this. So if I is less than 0, return false. So it's not valid if I is off the edge. So I is less than 0, or I is greater than columns, greater than or equal to columns. J is less than 0, or J is greater than or equal to rows. So if it's off, just that's false. Otherwise, return grid ij. This could be consolidated into one simple line of code, but I'm just basically checking, is this a spot that I can go? Oh, return not grid, because it's taken if it's true. I should not fill them all with true, and then I can't go there if it's false. Whatever, you work that out. How do you think about this? I was thinking about it's taken, I flip it to true, so it's valid if it's not true, if it's false. Oh boy, I really made a mess of that. But there we go. So when do I get an error here? If there are no options. So I can say if options.length is greater than 0, do all of that. Otherwise, console log, I'm stuck. And stop the program from looping. Let's change the spacing down back to like 10. And there we go. We have a self-avoiding walk. We're done. Are we done? In a manner of speaking, I'm done. And if a wise person would stop right here and say, now, as an exercise to the viewer, can you figure out how to, if you get stuck, go back and try a different direction? So that's what, I could make that a part 2, but I'm just going to plow forward. So if you want, pause, make something out of this. I think there's a lot of possibilities of things you could create. If you want to stick with me, I'm going to keep going and work on what's known, I think it's what's commonly known as a backtracking algorithm. So I have tackled this before. All of my maze generation videos, I think it's a 4-part series about generating mazes. Those involve a backtracking algorithm where I'm keeping track of everywhere I'm going. And if I get stuck, I can go back and try a different way. I get stuck again, go back and try a different way. So to do this, I need a couple key things. One is I will definitely need like a variable, I'll call it path, which is an empty array. And that will sort of keep track of what's my current path that I'm on, so that at any point I can like back up and try a different way. So I need that. Let me make a simpler, a 3x3 grid, I think will help us understand this better. Okay, I'm going to go to the right, I'm going to go down, I'm going to go down, I'm going to go to the left, I'm going to go up. It's to the right, but I turned left. And then I'm going to go up and realize, like, nope, no more options. So I need to then go back to this one. And I need to remember that I already tried to go this way. So now there's still no more options. I need to go back down here, and then I remember that I tried to go this way, so don't go that way, but I can see I can go this way. Oh, that's going to get me stuck. Eventually I'm going to realize I have to go over here from here. So I thought that diagramming this would really help. Probably if I had like a very clever animation to explain it, that would really help. But I think the way to make this make sense to you, the viewer, right now in the context of this video is I need an object. I think I need a cell class. Well, let's call it spot. So these are all of the spots, a class spot. And the spot will have that array of options, but the options have not just dx and dy, they also have a like a variable called like taken. Was it taken already? Was it tried? Maybe I call that tried, and it would be false at the beginning. So I'm keeping track of what was tried and what wasn't tried. Is that a grammatically correct sentence? I am not sure, but I'm just going to keep going. First step, let me make the spacing 100 so we can really see this very clearly. Oh, and I'm realizing everything is shifted a little bit up and to the left. I need to just like translate the whole world down a tiny bit. Translate spacing by half of spacing. Oh, I put that in setup. How silly me. That has to be in draw. There we go. Oh, look, I did it perfectly. That actually hit every spot. What a lucky coincidence. But most cases that won't happen. All right, so now it's drawn correctly, but I need to change it to say background 0. So now that I'm erasing the background, I don't see the full path. So let me add this variable called path. And then every time I go, well, I want to keep track of where I was. So I could make an object to keep track of where I was, but I think this is where I need that spot class. So I created a JavaScript file called spot.js and added it to index.html. And I just want each spot to keep track of all of the options. But how do I copy an array? No matter how many years I've been programming, I have to Google how to copy an array in JavaScript. It's just the way it is. For me, for you, for everybody. We all do it. Amazingly, though, I forgot that. Is this called the spread operator right here? Thanks to this webpage that I just found from SamanthaMing.com about how to clone an array. I forgot. I need to make a video about that spread operator. I will do that. I will do that. Mental note, remind me in the comments. And by the way, I can't just use equal because I need to make a copy because I want to manipulate it and I want the original array to stay the same. I'm going to use slice right now because I know slice will work. And eventually I'll learn this other ... operator. But also, I want the options now to each have with them a variable that keeps track of whether it was tried or not. So this is really becoming like a template. And by the way, if you're wondering why it looks like this now, I used the auto format, which then got rid of all my perfect spacing. Oh! So now each spot has its XY position. Oh, you know what I should do? Oh, I have an idea. I have a really good idea. This should actually be, the XY position should be its actual pixel location. And I'm going to call its index into the columns and rows I and j. That way, whenever I want to draw it, I can just grab the XY. And whenever I want to look up where it is in the array, I'm going to give it the ij. So now, essentially, here, this grid, instead of the grid just having false or true in it, I can put a new spot object to keep track of all the metadata associated with that spot there. Oh, and I guess the spot itself should know whether it was visited. And that would be false. So whether the spot was visited. So there's two. I'm not only keeping track of which directions out of that spot have been checked, but whether that spot has even been visited at all. And so I would say grid xy visited equals true. Also, path push grid xy, I should put that spot into the path. I see. Maybe I don't actually want that x and y variable at all. Maybe I do. I'm not sure. But I definitely need a variable called spot. So that's the current spot. So the current spot will be grid x, y. You know what? I've got it. I've got it. I'm going to get rid of this xy entirely. This makes total sense now. I don't need this xy. Whatever the current spot is, that's the current xy, but it's ij in there. Aha. So this will be grid. And I'm just going to start it at 0, 0. That's going to be simpler. I'll just start it in the top left. And then that spot has been visited, and it goes in the path. Then this code that picks the next spot, that should actually be in the spot object itself. Like spot should have a function called next spot. And there, I'll do this code. I'm just going to paste that there for a second. I'm noticing this will now be spot.x, spot.y, and all of this. I'm not going to worry about drawing it right now. Let's just take all of this. That should also be here. So I want, and I'm going to make this, it'll be a longer name, but it'll help. Valid options. Let valid options of this dot options check for the new x, and this is this dot I, this dot j. If it's valid, I still need that function. Push it into the valid options. If the valid options is greater than 0, do all this. I kind of want to take the drawing out for a second because I think that's going to be important to not have that in here. But definitely pick the next step from the valid options. And then return. I know I should just return the next spot in the grid. This dot I plus step dot dx, this dot j plus step dot dy. And then if I get to the end and there are no valid spots, return undefined. Is this really right? Find all the valid options for this particular object. And I'm also going to have to check whether was it tried already. But I'm going to get to that. Right now, I'm not going to worry about that. Why do I have an error here? Not a comma. This is a two-dimensional array. That's the next spot in the grid is this dot I plus the step, this dot j plus the step. So back in Sketch, let next spot equal spot dot step. And actually, the spot, I'm just moving to the next spot. Is it called step? Next spot. So many. Spot dot next spot. Boy, I could really use some naming help here. If there is no spot, console log I'm stuck. I don't know why I'm saying I'm. There is no, it's not a person. It's not an I. It's a thing. I'm just going to say it's stuck. Right. There's almost zero chance that I haven't made a mistake here, but in theory, this should be exactly what I had before. Option is not defined, spot line 14. Oh my goodness. This is let option. That should not have changed to valid option. That was the option of all the options. Check every option, see if it's valid, put it in the valid options. One mistake. Stuck. Interesting. Did it go anywhere? I didn't think it going anywhere. All right, I got to debug this. Console log spot. Okay, the very first spot was undefined. Let's see, did I get some valid options for that spot? No. Oh, my isValid function is no longer correct. It is valid if it hasn't been visited. So if grid not visited. I forgot that I made each spot in the grid an object, so I have to explicitly check the visited Boolean variable there. Let's see what happens now. Ooh, it seems to be having a fine time going forever. Oh, I'm not setting the thing visited when I got there. So right here, this setting of the spot to visited in setup, I should be doing that for every new spot, every time in draw. So I'll just put that right at the beginning of draw. And let's try this again. All right, then it gets stuck. I can get rid of this console log valid options. I want to put back in the line. Well, actually, what I want to do, before I put back in the line, the whole point is I have that path variable. So every time I get a new spot, I'm going to put this also in draw. I'm going to push the spot into the array, and then I can draw everything. So now this should be drawing the line through all the spots. Perfect. So I could keep drawing circles and lines or whatever, but I kind of like the way this is visualized right now, so I'm just going to keep it. Getting really close. I mean, I've left the most difficult, I think what is the most difficult part to the end, but hopefully I've built a pretty good foundation for doing this. I need to backtrack. So if there are no spots left and I'm stuck, instead of just stopping, what do I need to do? I need to go back to the previous spot. Let me just save previous. I'm going to temporarily save the previous one so that if I'm stuck, I can say spot equals previous, and I can try another way. Let's just see what happens if I do this. Well, there aren't other ways for it to try every time it's stuck. I can't tell if it's going back and trying a different way. Oh, but that's the spot that's stuck. I can't try a different way in the spot that's stuck. I have to remove it and go back to the previous one. Oh, that's easy. I have it in an array. Never mind. I don't need this because I have it in an array. If there's no spot, path dot, let's get rid of one, pop. Stuck equals path, take that spot off. I'm stuck, so pop that spot off the path, and then the spot is now the last one in the array now. Is there something called pop that I could do without removing it from the array? I'll just say path.length minus 1. So I'm just getting rid of that spot and going back one. I can't tell. Yeah, did you see it went ahead and then it went back? I think that's, it's still stuck. So something is kind of working here, but I'm missing so many important steps that I can't tell if I've really got this right. The thing that I haven't implemented at all is whether a direction has been tried or not. Remember, with all the ways that the walker could go, I set all of those possibilities as tried false to start with so that I don't try them again. So right here, if I am going to pick this particular option, this step, I need to set that it's been tried. Then, as long as it's a valid option and that option was not tried already, then it is a valid option. Options is not defined. Oh, and option.tried. Getting stuck pretty fast. Oh, well, certainly one thing that I need to do is once I'm removing it, it's cleared. Like it's not part of the path anymore. Any ways that I tried, I could be coming at it from a different way. So I should clear all of that. Meaning, I'm gonna call a function called clear. And definitely say it hasn't been visited, like I haven't been visited, and reset all of its options. Okay. I'm very close, I think. Now this is going to be really challenging to debug. I'm not really sure how I'm going to do it. Because obviously it's kind of working, but it gets stuck immediately. I think maybe there's an issue with the fact that I'm adding it to the, I think I should only add it to the path if it's valid. So I think if there's no spot, otherwise, I shouldn't be, I'm always adding it, it's just getting added back in. So I should only add it to the path if it's the next spot that's valid. And then in that sense, and say that it is visited, and in that sense, maybe I will go back and just do a one-time add in setup for the first spot. I think I got a little bit closer there, but it's really not working. Oh boy. I'm going to try setting the frame rate to 1. Okay, let me set the option, the spacing back to 100. So the point is always 1 point behind, and then, it gets off. Visually there, I mean, there might be a better way to debug this, but visually I'm seeing something quite off in that the end is like lagging behind, and then all of a sudden it skips ahead, and then that's lagging behind, so something's really wrong. Oh, well, it has to do with drawing this here. What if I draw it down here? I mean, it shouldn't make any difference. Oh yeah, now it's at the end. Oh, it's backing up. It definitely is backing up, but it's not able to try a different way. I'm just going to shut off this step.tried for a second. Aha. Okay. This is right now in that it is going back and trying other ways. I think I'm realizing that this is a major error right here. All options.slice. I am making a copy of this array, but inside the array are 4 objects. and he didn't copy each and one of those 4 objects. I really should make this into a class. Like, I should make a step class. I was trying to cut corners by just using some object literals, and I think I let myself into a big problem. I led myself down into a major error there. Oh boy. So I'm going to add another class here. I'm going to call it a step. Every single step has a direction. It's either left, right, up, and down, and whether it was tried or not. And instead of just copying from a global array here, let me write a function called allOptions. And I'm going to manually make a new array with new objects in it. Everything's brand new. It's a new array with new objects. New step 1, 0, comma. So now this function, allOptions, will make an entirely new array of new objects, all with visited set to false. Because I was setting visited on one, and it would set them, then every single spot everywhere had thought it had visited everybody to the right and left, and it was a mess. Not visited, tried. Visited is for when you've been there. Tried is for when you tried to go there. This is very dramatic because I set the frame rate to 1 while I was debugging. Yeah. Oh, it's going. It's trying it. Let's set that frame rate up. Back to 60 frames per second, everybody. It's trying all the possibilities. It's going to get it eventually. Oh, I'm not sure I set any condition to stop when it gets it. It might have gotten it already. All right, let's set a condition for when it needs to stop. So when is it done? If it's hit every point. All right, so if the path has as many spots in it as every spot on the grid, it should be done. I'm gonna try running this again. It'll take a little while, but hopefully it's going to stop, and we'll see console log solved right there in the console. I'll wait. Oh, I got there. Let's pump up the resolution a little bit. I should point out that this is a brute force solution, so I don't actually know if this is ever going to end. I'm going to wait a little bit longer. While this is running, I'll also point out that I probably should have used recursion for this. So I will include in this video's description a link to a version of the code with recursion, a function that calls itself. Maybe that would have made it easier, more elegant, more beautiful. I'm not entirely sure. I can come back and revisit that in another video, but for now, I kind of like the way that I had to work it out this way. Okay, I'm much too impatient. I want to know that this really works. So if I look here at the draw loop, I do see that this right here is me checking for the next spot. So there's no reason why I couldn't just ask to do that multiple times per frame, which won't make the algorithm go any faster, but I will do multiple times through the algorithm per frame of animation, which will let us experience it in a faster way. So let's just try saying for let I equal 0, I is less than, let's just try it 1,000 times each frame. And then also, if it's solved, not only do I want to say no loop, I want to break out of that loop. And let's see what happens here. Yeah, so you can see you can sort of see the speed at which it's getting through all the possibilities. Now, 1,000 probably isn't even enough for me to make any significant progress here. Let's try 100,000. I am much too impatient. I'm going to go up to 500,000. Oh, you can see the frame rate is starting to dip now. So at a certain point, it's sort of diminishing returns here. I might be able to get more checks through one cycle of draw, but if the animation is going too slow, then what's the point? All right, I'm going to hope that this actually ends at some point in the next. Somebody can probably calculate the number of possibilities and the probability that I would have get it within a certain amount of time. Well, this doesn't seem to be finishing anytime soon. I'm trying to think about what the big O notation of this algorithm. This is a brute force method. Doing a little research about this while I'm waiting for this. Also, it should be clear how this is a graph theory problem. I have a graph. In other words, I have a system, a 2D grid. Each one of these spots is known as a node. The nodes are connected via edges. And I've done several problems and other coding challenges. I'll put links and all the stuff flying around to those previously in the video's description. But essentially here, I have the algorithm that I'm using to find a self-avoiding walk that hits every spot, even in just an 8x8, right? So it's n squared for sure, in the sense that if n is 8, there are 64 spots. But then for every spot, I need to check every other remaining spot. I think this is going to be like n squared factorial or something insane. Oh, that's a big number. I did a quick calculation here. That's what I got for 64 factorial, meaning it's 1 with 89 zeros. So I don't think this is finishing anytime soon. So definitely, I will need to revisit this with a more efficient, optimized algorithm. I could probably find one just to point you, the audience, to very quickly. So first of all, look at this. Calculating the number of self-avoiding walks in any given lattice is a common computational problem. There is currently no known formula, although there are rigorous methods of approximation. I see here that there's a pivot algorithm to try randomly choosing a point and then applying symmetrical transformations. Well, as we can see here, I'm finding a lot of interesting papers about self-avoiding walks, and I realize I'm definitely going to have to do some more research into what are some known optimized methods or techniques for approximating a solution to a self-avoiding walk. This kind of reminds me of the traveling salesperson problem, which there's, I'm sure, some relationships here as well. Maybe I could use a genetic algorithm to try to evolve an optimal self-avoiding walk. I have no idea. I hate to stop this because someday it's going to end. But what I'm curious to do right now is just go back to doing it just once per frame and upping the resolution quite high to something like 5. I'm going to hit save. I think, you might find that this, even on its own, is quite beautiful. Just the process of trying every possibility in a space so vast is really quite delightful to look at and experience. And I think there are probably many unique visual outcomes that could come from this. One I suggested is try extending this into a 3D space. What would happen if you did that? I'm sure you can think of ways of playing with color and other kinds of generative visuals or tying this to something else. I look forward to seeing what you make of this code. I will certainly revisit this in a live stream at some point after this is released. So at some point, hopefully you'll see a link in this video's description to a live stream where maybe I look at some other examples and make some further improvements to this. But if there is a kind of optimal, a better algorithm that I can investigate and come back and do a video on, I definitely will. So let me know in the comments. I'm sure I made countless errors here in this video in terms of talking about the big O notation of this particular brute force methodology, but I hope that you enjoyed this video. And I did actually make a self-avoiding walk, and I'll see you sometime else on the coding train. Goodbye.